Alright, so I have the LRP. This is the X22 Stock Spec. It's a very nice looking motor. This is what the box looks like. So it's a nice little packaging. Now, a few little things about this one. So just based on visual inspection, many motors use this type of connector here. So this isn't particular to LRP. Trinity has used this. I mean, LRP has used this in many other motors. They're all right. They're not my favorite. I actually prefer this type of terminal. Just easier to set the wire. But you really don't need that much on the terminal. The end bell, the reading is on top, and it's pretty simple, pretty easy to read. But I wonder once the wires are here, if the wires are coming out this way, how easy that will be to read once you have 3 wires soldered on there. Might not be a big deal. Usually you just set the timing and then just run it as is, and then mess around with the gearing. So it may not be an issue. Just one sensor port. These little things, they're just there to look cool, maybe drop some weight, I guess. But the design of the body, this thing's pretty nice. The screws are a little thicker. Based on that, I will be removing them in a bit compared to, say, the Surpass. Surpass are much thinner. So this one does have more robust screws holding everything together. Now, let me see what the laminations are. At least the thickness here. Let's see if I'm getting this correctly. All right, so it's about 20. That's what most of them tend to be for the laminations based on this measurement. All right, this plate here, well, the inside, that looks very similar to the Surpass, which is also similar to the R1. But to be honest, if it works, it works. You don't really have to reinvent the wheel with some things. But that insulator right in there, that's pretty thick. I don't see that in this motor. This is the Surpass that I did earlier. But this is a pretty nice motor. So we'll go ahead and take it apart. I'll measure the gauss from the rotor that comes here. And then after that, I'll measure the kVs and I'll give you a weight. Most motors like this, they tend to be somewhere around 140, 160, somewhere around there. But we'll see how much this one actually weighs in grams. The rotor was somewhat of a pain to get out. This is the rotor. So this is LRP. That's the number that it comes with. And this should be a 12.5, so we'll see. Now, this one looks very similar. I think it looks just like a Hobbywing rotor. Very similar. I'm not going to try and interchange them. That's not my goal. But it looks similar. All right, so 25. That's a 25 millimeter. Let's see if this is a 12.5. 12.5. 1248. That's 12.5. All right, so that's pretty nice. So we'll measure the strength. And one of the things that I like too about the LRP is the insulators. They put insulators everywhere. And the weight is not bad. The weight of this particular motor is 149 grams. So 149. All right, so it's not bad. It's definitely not the best, but it's not bad. So this is 1627, 1607. Now, assuming the stator is similar to some of the other motors that I've tested, for example, Hobbywing, Helix, even the Surpass or the slot machine, given the lower gauss, this is 100 gauss less than the Surpass. So I would expect more kV, but we'll see. So here are the gauss comparisons, so really quick. So the LRP X22 Stock Spec 21.5. This is the rotor number, so this is a 520522. The gauss is around just over 1,600, so just over 1,600. Now, this here, I believe this is probably similar to R1. And to be honest, I mentioned how that plate was very, very similar. Oh, no, actually, R1 is higher gauss. So I'm curious how they did in the KV. So based on these gauss numbers, if, for example, this Surpass had a similar rotor to this, but 100 less gauss, you would expect more RPM out of it. That's usually the way it goes. But more gauss, more torque. So this one will, in theory, spin easier. And one of the things we're probably going to see is, in order to achieve the amp draw, say if you're looking at 5 amps, something that's around 1700 will generally achieve 5 amps at probably 48 degrees. Something with about 1600, you're going to be over 50 degrees. So that's going to be one of the differences. So it just depends on application. It also depends if you're planning on running boost or turbo later on. So having less gauss isn't necessarily better or worse. It's just a different application. It depends on what you're using it for. And that's something that we found with, we find with some other motors. So, Team Powers, well, this one just used a small rotor altogether, smaller diameter, 11.5, I believe. I could be wrong. I would have to check that video again. It's something I just realized I don't record. But now I'm going to go over and test the other reading. Oh, this is interesting. It's similar gauss to the Phantom 25.5. Fascinating. Anyway, so as expected, it does take a lot more timing to get the amps that we want. So to get close to that 5, this is as close as I could get to 5. I kept messing around with. One of the things that I noticed is there's a huge spread, 51, 50, 55. But once we move up here, 59, 51, 59. So this it's the little end bell. So all you have to do is you take that little end bell and then just sort of shift it as you're tightening it. And then make sure you tighten everything evenly because that'll throw it off. But that's a huge difference once you get this high. Over here, it's just 5 and 4. Here, we're looking at 8. It's double. But anyway, not a big deal. This will actually usually give you a little more speed, a lot more speed. So that being said, 5.2 amps, we achieve at 56. Now, a quick note, 52 degrees. I had the end bell, when I first started it, I actually set it to what I thought was approximately 45. So based on the little hash marks, it was between 40 and 50, as close to center as possible. Then I shifted it up a bit, and this one here, this is about 50. So I set about 50. So the hash marks and the actual timing is way off on this one. And it's not uncommon for some motors to be way off. That's why you have to be careful when you're using everything, because let's just say you move it mechanically to 60, you're going to be way over 60. So I'm wondering if LRP, if these motors are really, really fast, not necessarily because they're really, really fast, just because the hash marks are off. So one is actually running much higher timing than one thinks. I have no idea. But anyway, right, what's their slogan? It's something about blue is better. That's what they say. But let's see. Speed-wise, it's pretty fast. It is quite fast. So here we go. Let's go ahead and compare it to, let's see, so I'm at the top here. We'll ignore the V3. There's really no point. But even if we look at the V3, if we look at that 5.6, we're looking at almost 3,000 RPM. So that one is higher at less RPM. Oops, yeah, 53. Here we go. But V3 is somewhat old. So we'll look at the V5. So V5, 5.3, that's close enough. So this one is 150 kV faster. That's pretty good. Actually, it's more than 150. But, well, I'm not going to do the, well, I guess I could. So let's see. So that would be 22, and then you add it to this, so that's 61. So 161. So that's pretty good. Timing-wise, though, this one's at 56, this one's at 50, so that's something to consider. This one will achieve this kV at lower, let's see, same amps, lower degrees, kV. So this one might have more torque, this one might have more speed. So if you're choosing between the two, that might make a difference. Traxxas, yeah, Traxxas. It's good for the price, though. I don't remember how much I paid for this. I believe this was $50. You can't beat. I mean, this thing's amazing for $50. I think that's how much I originally paid for it. USGT, I'm not even going to bother. That's for spec class. That's fixed timing. But let's keep looking at, let's see, do I have anything close? Not really, but if we look at this 5.6, so LRP is definitely doing, here we go, LRP is definitely doing more kV. Not quite 100, but we're over 60. So we are over 60 kV at less amps, but it's a higher timing, so that's something to keep in mind. The LRP is probably going to be your speed motor, that Xfactor is going to be more torque. And if we move on over to the slot machine, we are going to see something similar. And actually, I should copy that data down here and then compare them. But let's see, we're about 2739, so let's say 2740 at 5.2. So the Helix is going to be faster at less degrees. Slot machine, we are looking at, so the LRP is going to be faster than the slot machine, but the slot machine is at less degrees. So the question is, do you go by timing or do you go by amps? I would say go by amps, but that's up to you. So again, the application is going to be very, very important. The LRP is probably going to be your speed motor. You're probably going to have to gear down. Your slot machine is probably going to be a more torquey motor. Probably you're going to gear up. So those are some of the things to keep in mind. Why am I saying that? Because it achieves the same amount of amps, roughly, less kVs at lower timing, mainly the lower timing. Let's see, R1. This is the one I really want to compare. Oh, I don't have a 5. So 57, 4.6, 25.9. This one will actually be pretty close. Let's see, LRP. I think this is who LRP is trying to compete with. Let me go ahead and, well, actually, here, let me just go to the R1 and I'll just read off the LRP. It'll be easier than for me to try to change this table now. All right, so 4.6. Now with the LRP, we have a 4.5. That's what we have. And that 4.5 is achieved at 55 degrees versus 57. And the KVs for that 4.5 are 2656, so pretty close. So I would say the closest competitors here would actually be the LRP and the R1. Those are probably the two that are the closest, and then Xfactor. So I guess it's going to depend on your application. LRP is probably going to respond pretty good to boost and turbo, probably just if you want RPM. It's really going to be up to you and decide if this is what you need, this is what you want. But these are the specs. Now, I don't have more data points compared to some of the other motors because there's really no point. I went from 3.3 amps to 5.2, and I have a 4.5 and a 5.2, so those are really the numbers that I'm looking for. And if I bump the timing up a degree and I accidentally go over 60, my analyzer can only read up to 60 degrees of timing, so it'll say timing is out of phase, and it won't read the timing. So that's as high as I can go, unfortunately, with my instruments. But that's it. So that being said, I hope this video was informative, at least entertaining. Thank you very much for watching, and I'll catch you in the next one.
Oh, my hair! My tongue! My room!